Hello guys, you are welcome to this series, and in this video we are going to answer some of the pharmaceutical chemistry questions and answer, or we are going to provide solutions to some of the pharmaceutical chemistry questions. These are my study questions that I draft out during my study session, and I want to see if I can actually provide solutions to them without looking at the book. So you may join me. Now, I'm also going to provide solutions to the previous questions on this course, like previous year's past questions, previous year's question on this particular course. Okay, let's begin. About 99% of dash is deposited in the bone and teeth. The rest is found in body fluid as electrolyte replenishers and as dash for treatment of hypocalcemic condition. What is the correct answer? What is deposited in the bone and teeth? The correct answer is calcium ion. The calcium ion, about 99%, which is calcium 2+, is deposited in the bone and teeth. The rest is found in body fluid as electrolyte replenishers and as calcemic. So here, supposed to be calcemic, something like this. Calcemic, or without the E, for treatment of hypocalcemia. Let's say it's calcemic for treatment. I just feel A should be here. For treatment of hypocalcemic condition. Serious lack of calcium ion leads to, now the answer is visible here. Serious lack of calcium ion is called hypocalcemia. Is called hypocalcemia. Serious lack of calcium ion is called hypocalcemia. The major source of calcium replenishment therapy is calcium chloride. The major source of calcium replacement therapy is calcium chloride. Now let's look at the next. Two functions of calcium ion is: one, it helps in normal muscle and nerve functioning. It helps in normal muscle and nerve functioning. And two, this one, and two, it also helps in blood clotting. It also helps in blood clotting. Okay? Now give three sources of calcium ion, which is calcium. Three sources of calcium. Now we have one. The first source is calcium chloride. Calcium is gotten from calcium chloride. It is gotten from calcium carbonate. It's also gotten from calcium hydrogen phosphate. Then we can also get it from calcium lactate BP. So all these, of course, we know the meaning of BP, British Pharmacopoeia. It means it is official. We can find the ingredient for the preparation of this calcium lactate BP, or the calcium lactate in the British Pharmacopoeia rather. So those are the three sources of calcium. So if you are asked, give three sources of calcium, you can say it's calcium chloride, calcium carbonate or calcium hydrogen phosphate, calcium lactate BP. All these are major sources of calcium. Okay? Now, the second most predominant cation in the intracellular fluid compartment is magnesium ion. Correct answer is what? Magnesium ion. That is second most predominant, or you can say magnesium 2+ ion. Magnesium ion is replaced through the use of magnesium chloride. In short, we can write it as MgCl2, or magnesium lactate BP. Magnesium ion is replaced through the use of magnesium chloride and magnesium acetate. Don't think it's lactate, this is acetate. Magnesium acetate BP. Okay, magnesium acetate BP. Something just occurred to me now. Another source of calcium is calcium gluconate. Calcium gluconate. Okay, so those are sources of calcium: calcium chloride, calcium gluconate, calcium carbonate, calcium hydrogen phosphate, and calcium lactate BP. Now, magnesium ion replacement is through the use of magnesium chloride and magnesium acetate BP. Now, magnesium is essential to life. This is an extract from the material direct. So if you have read the material very well, you should be able to answer these questions. Now, magnesium is essential to life as it is a Dutch in numerous Dutch systems involved in phosphate transfer, muscle contractility, and neuron transmission. The correct answer is magnesium is essential to life as it is a cofactor. As it is a cofactor in numerous enzyme system. When you say cofactor, your mind should go to what? Enzymes. Okay, magnesium is essential to life as it is a cofactor in numerous enzyme system involved in phosphate transfer, muscle contractility, and neuron transmission. Now the next, classify or name inorganic compound used as gastrointestinal drugs. This is one of the exam questions. What do you think will be the answer? Classify or name inorganic compound used as gastrointestinal drugs. Okay, let me try and remember. Number one, we have compounds that alters gastric pH. Compounds that alter gastric pH. They either increase or what? Decrease gastric pH. Okay, that is one. Compounds that alters gastric pH. Number two, we have number two should be adsorbents for intestinal toxin. Intestinal toxins. Then we have three, antacids, antacids, and then finally number four, we have cathartics or cathartics. I don't know if my spelling is correct, or laxatives. So these are the four classes of inorganic compound used as gastrointestinal drugs. Now the next question say lack of HCl in gastric juice secretion is called achlorhydra. Something like this. Achlorhydra is the lack of HCl in gastric juice secretion. Lack of HCl in gastric juice secretion is called achlorhydra. Now let's look at the next one. When there is achlorhydra, what can be taken? What can be taken when there is achlorhydra? We can take dilute solution of HCl. But this is not advisable because of the acidic nature of HCl. Now, because of the acidic nature of HCl, it may cause why am I forgetting this thing? I will try to remember. Okay, when there is alcohol, what can be taken? We say dilute solution of ACl. Now, because of the acidic nature of ACl, it causes irritating action on mucous membrane and also injuries to the enamel or to the tooth enamel. Are we getting it? So these are the two things that it may cause. So it is not often recommended, but a mixture the one that is advisable for use is glutamic acid. We can use glutamic acid hydrochloride, or we can use glycine hydrochloride. So these are the tools that can be used in place of dilute solution of HCl. Okay, now the next, what are antacids, and give the properties of antacids. Now, antacids are substances that are used to neutralize gastric acidity. Are we getting it? There are substances that are used to neutralize gastric acidity and to also inactivate proteolytic enzymes such as and also to inactivate proteolytic enzymes such as pepsin. Pepsin is an enzyme that works on protein in the stomach. So antacids, sometimes they would inactivate these enzymes, and antacids are generally taken to do what? To neutralize the acidic nature or acidic secretion of the gastric juice. Are we getting it now? So that is what an antacid is. Now, what are the properties of antacids? Properties. One of the property is it should not be absorbable. It should not be absorbable. It should not be absorbable. Then two, it should not cause constipation or it should not cause constipation or should not be used as a laxative. Should not cause constipation or it should not be used as a laxative. Then another thing is it should be rapid. And its effects should be long lasting. Okay? Should be rapid and its effect should be long lasting. Then another one is that it should buffer between, I think that is 4 and 8. Should buffer between 4 and 8. Not 4 and 8, but 4 and 6. It should buffer between 4 and 6. It should not be absorbable. There is something I'm forgetting here. This is absorbable. And I think, and it should not cause systemic alkalosis. Should not cause, let me put hyphen here, systemic alkalosis. And then it should probably inhibit pepsin. We said it before when I said it before when I was defining the antacid. It should probably inhibit. It should probably inhibit inhibit pepsin. Okay, so these are the properties of antacids. Now list 4 inorganic substances used as antacids. 4. So number 1, I take aluminium hydroxide. At least this one is pretty easy. What other one again? The one that was assayed in the lab today, magnesium sulfate, is an antacid. Then what other one again? Aluminium hydroxide, magnesium sulfate. We have calcium carbonate, or let me say calcium sulfate. Then number 4, almost all the salts here are antacid. Aluminium hydroxide, magnesium sulfate, calcium sulfate. We have calcium carbonate, and we also have bicarbonate. All these are antacids. The bicarbonates, all these are antacids. Okay, now give the name of any combination antacid, what inorganic compound it's contained, or what inorganic compound is contained in it. Example of combination antacid is aludrose, and there we have another example is jealousy. Aludrose comprised of aluminium hydroxide, gel magnesium hydroxide, aluminium hydroxide, gel magnesium hydroxide, and then jealousy comprised of aluminium hydroxide, gel magnesium silicate, gel magnesium silicate. So these are the 2 combinational antacid or combination antacids. Okay, now the silicate used here is trisilicate. So we have 2 combinational or 2 combination antacid, and these are the substances they contain. Aludrose, which is aluminium hydroxide, gel magnesium hydroxide, and then we have jealousy, aluminium hydroxide, gel magnesium trisilicate. Now the next, state any 2 reasons for the formulation of inorganic antacid as combinational product. Now 1 is to counterbalance, or we can say to counterbalance the constipative effect of aluminium and calcium with the laxative effect of magnesium. And then 2, to allow for long duration of action. Or if we want to state it as it is in the material, we can say to provide for suitable duration of action. I think this one is making more sense. To provide for suitable duration of action. These are the 2 reasons for the formulation of inorganic antacid as combinational product. Now list 2 serious side effects of inorganic antacid. What are the two serious side effects of inorganic antacids that we know? We have peritonitis, which is inflammation of the membrane lining the abdominal wall and covering the abdominal organ. Then I think another one is constipation. It can lead to constipation, and it can also lead to alkalosis. Okay, so these are the three medical conditions or three side effects of inorganic antacids. Now the next question: what are pharmaceutical aids? Now, pharmaceutical aids includes all combination of excipients that are required for formulation of drugs into suitable dosage form. Now, what are the categories of pharmaceutical aids? What are the categories? Can I still remember this particular question? What are the categories of pharmaceutical aids? I think we have I think solvents. There we have acids / base / buffer. We have tablet aids. We have clarifiers or filter aids. Tablet A, clarifier or filter aids. Then we have glass container. These are the ones I can remember. These are the categories of pharmaceutical aids. Okay, now the next question. So when you are asked to name the categories of pharmaceutical aids, what should come to your mind? We have the solvent, we have the acid, base, and buffer. Then we have tablet aids, clarifiers or filter aids. Then we have the glass containers. So those are the categories of pharmaceutical aids. Okay. Now the next. The acid of choice for pharmaceutical neutralization is HCl. Example of pharmaceutical aids used as clarifiers and filter aids are. Examples used as clarifiers and filter aids are, I think, activated charcoal, and purified talc. These are the pharmaceutical aids used as clarifiers and filter aids. Now, I've done this before. The choice of acid for pharmaceutical neutralization is HCl. An example of pharmaceutical aids as clarifier and filter aids are activated charcoal, which can also be written as charcoal, and purified talc. Now, tablet aids include, you have the hint here, BDD. B is for why am I forgetting this? Okay, let me remember D. D is for diluent. Okay, B is for binder. D is for diluent. This other D is disintegrant. And then finally, the last L is called lubricant. So these are the tablet 8. You have the binder, we have the diluent, disintegrant, and lubricant, which is given as BDDL. Are we getting it? Then dash are substances used to prevent oxidative decomposition of pharmaceutically active components. Correct answer is antioxidants. Are substances used to prevent oxidative decomposition of pharmaceutically active components. Most commercial glasses are made up of this thing, vitreous silicate, something like that. Vitreous silicate. Please, you can help me confirm this if it's correct. Let me confirm before I post the video. I think it's vitreous silicate. Let me reach out to my books and see. This one I'm not too sure about it. Examples of glass used are vitreous silicate. Let me see. Very addition types of glasses. Most commercial glass are made up of vitreous. Okay, I'm correct. Vitreous silicate. I'm correct. Vitreous silicate. Okay. So that is the correct answer to that. But the vitreous is spelled V-I. This is spelling V-I-T-R-O-U-S. Silicate. Now, what are topical agents? Now, topical agents, they are agents or they are compounds. We can say they are compounds. In this case, we are talking about inorganic, that are meant to be used on the body surface. That are meant to be used on the body surface. That are meant to be used on the body surface. Those ones are called topical agents. Topical agents are classified into two, which are protective and antimicrobial or astringent. Okay, so these are the two types or the two ways in which topical agents are classified. They are classified as protective or antimicrobial agents or astringents. Antimicrobial agents or astringents. Okay, so these are the two classifications of topical agents. Now, let's take the following objective questions together. These are from the past questions. Which of the following organic ion is the most predominant cation in the intracellular fluid? Predominant cation in the intracellular fluid. The correct answer is option B. Calcium is the most predominant cation in the intracellular fluid. While the extracellular fluid, the most predominant cation is what? Sodium cation. Okay? Now, the following are inorganic oxidizing microbials used as antiseptic and disinfectant, except now every other thing here. Chem level 4 is used, hydrogen peroxide is used, iodine is used, but zinc oxide is not used. Okay, zinc oxide is not used as an antiseptic and disinfectant. Okay, so that is the correct answer because we are looking for the one that is except. So the correct answer is zinc sulfate. Zinc oxide rather. This is the correct answer. Now the next one. Okay, stay the same question. Now we have an equation here. The equation says, in the equation above, barium chloride was treated with excess sodium silver chloride to yield, silver nitrate to yield silver chloride precipitate. if the silver chloride precipitated is 2.7 gram, 5 gram, how many grams of barium chloride was used and how many moles of chlorine were in barium chloride? Now, how do we solve this question? We must know the mass, the molecular mass of barium chloride. Molecular mass of barium chloride. Where is the molecular mass of barium chloride? It was not given, but we have to know it. Now, the molecular mass of barium chloride is 208.23 gram per mole, and that of silver chloride, because they are the two most important compounds to us in this question. That of silver chloride, I think, is 2338.38. I can still memorize that one. Silver chloride is molecular mass of silver chloride. I'm searching it for it. Molecular mass of silver chloride. Now, these are supposed to be given to us in the exam, so you don't need to memorize. Okay, it's not that 233. That should be barium sulfate also. Barium sulfate. For that practical exam. Now, this one is 142 or 143.32 gram per mole. Now, but you discover that in this question, 2 moles of silver chloride was precipitated. So we multiply this by what? 2 to get the total amount. Are we getting it now? So when you multiply this by 2, it's going to give us, this will be 2 times 143.32, and that will give us 286.64 gram per mole. So that is just the whole thing that we need. Now let's go to a new slide and see how we can solve this question. You have barium chloride plus silver nitrate to give us silver chloride 2 molecules plus barium nitrate. I believe this is the equation of reaction. Yeah. Now, silver chloride is 2. Barium chloride, this silver nitrate is in excess. It was stated there. Now, this silver chloride is the precipitate. So we come back here and say 208.23 gram. So we can say 208.23 gram of barium chloride gave, what is the mass of silver chloride as calculated? You know why we multiplied it by 2? The reason is because there are 2 moles here. Are we getting it now? So you must multiply it by what? 2. If not, your stoichiometry is not correct. So this one gave us 286.64. So you come here and say 208.23 gram of barium chloride, according to the equation, gave us 286.64 gram of silver chloride. Therefore, you are now coming back now. What was the mass of silver chloride that precipitated out of the reaction? The mass of silver chloride is 2.75 gram. So we are going to come here and say, if 208.23 gram of barium chloride gave 286.64 gram of silver chloride, therefore 2.75 gram of silver chloride would be equals to what? X. So at this point in time, you cross multiply. This multiplied by this will give us 286.64x is equal to 208.23 times 275 gram of barium chloride will be formed in total. So this divide this 286.64 divided by 286.64. When this cancel this, your x will be equal to 208.23 times 2.75 divided by 286.64, and this one gave us 1.997 gram of barium chloride. So we can say that 2.75 gram of silver chloride gave us 1997 gram of barium chloride. Okay, now the question now is, how many moles of chlorine were in barium chloride? How do we get that particular one? How many moles of chlorine were in barium chloride? Now, for you to calculate the moles of chlorine in barium chloride, you must calculate for the mass of chlorine in barium chloride. Now, you are not going to write the calculated mass that you got. The calculated mass is approximately 2, which is barium chloride. Calculated mass from this equation is 1.997. I believe so, 1.997 gram. Okay, 1.997 gram. Now, how many chlorines are in barium chloride? Because the question says, how many moles of chlorine were in barium chloride? How many atoms of chlorine are in barium chloride? You have 2. So you now say those 2 chlorine atoms divided by barium chloride times 1.997 will give us the actual mass of chlorine in 1.997 gram of barium chloride. Because now you see that barium chloride, the mass of 1.997 is a combination of both barium and what? Chlorine. But if you do this now, you now get just the fraction by chlorine alone in this 1.997. So if you calculated for the mass of chlorine, you should be able now to determine the mole of chlorine by noting that number of moles is what? Mass over molar mass. Now, how do we now go about this? This becomes 2 times the atomic mass of chlorine is what? 35.5 divided by what was the mass of barium chloride given in this question? 208.23 grams. So we come back here and say this divided by 208.23 gram. 0.23 gram times 1.997 gram. When you multiply this, it's going to give us 71 divided by 208.23 times 1.997, and that one will give us 0.681 gram. So the mass of chlorine present in barium chloride is 0.681 gram. Now, to calculate the number of moles of chlorine, what is number of moles? Number of moles is mass over molar mass. Now, what is the mass of chlorine present there? 0.681. Where is the molar mass of chlorine? 35.5. And this will become 0.681 divided by 35.5. And that will give us 0.0192 moles. So those are the number of moles, or that is the number of moles of chlorine in barium chloride. And that is the solution to this question. So I believe we pretty come to the end of this section. And if you follow through this question, you agree with me that we're almost done with the Pharmaceutical part of the question. The other question I did was from Mr. Vicocin. So please make sure that you follow through to the end. I'll still upload others before the exam tomorrow. Thank you. This is what's the answer to this one the other time? Zinc sulfate, zinc oxide. That was the answer we chose. Okay. So that is that for now. Thank you for your time.